The second part of 4.5 is finding the future value of money using a slightly different equation than we looked at before. You'll notice that the first part of this equation looks like the one from the first part of 4.5. It still has the p, it has the 1 plus r over n to the nt power, but now we have some additional things in there as well. The minus 1 wasn't there before, and this r over n wasn't there before. So P is going to stand for our periodic payment. So the reason this is different than the other one we invested a lump sum of money one time. This one we're going to keep putting in money, usually it's monthly, to an account. So like 150 every month is what our first example is using. We're going to keep putting that in. So we're going to try to figure out how much we're going to have over time. And this is what people do to save money for retirement. So once you get a job, you can decide how much you want to invest and start putting away money so that you can use it when you retire. So if we're going to invest $150 each month into a 401k retirement fund, it's expected to grow at 8.4% over time. If you start investing at 23, how much will you have in, first up, 10 years? All right, so let's take a look at this big old long equation here. So 150 is the payment that we're going to put in. We have 1 plus our rate, so we have to change that to a decimal, 0.084. We're putting it in monthly, so that would be 12 months in a year. And this 12 out here is the same, times 10 years. We have a minus 1 out to the side. And then we're going to divide all of that by 0.084 over 12. All right, so now you have to be really, really, really careful how you type all this into your calculator, making sure I would do this top part first. So do the stuff in parentheses to this exponent minus 1, hit enter. Then divide by this, but make sure you put this in parentheses, and then multiply times 150. If you got $28,062.82, you typed it in there correctly. What's pretty cool about these things is if you take 150 times 12 months a year, you're investing $1,800 a year times 10 years. So you took your own money and you put in $18,000, but you're getting $28,000. So by doing nothing, you made $10,000. Not too bad. But most of us don't retire in 10 years. So let's see how much we would have after 20 years. We're going to do that and same equation again. Everything is exactly the same. The only thing we're going to change is the time. We're going to change that to 20. Okay, and that's up in the exponent there. So everything else is identical because the rate stays the same. Still compounding every month, still putting in 150 every month. See if you can calculate what you would have in 20 years. You definitely want to practice putting this into your calculator because it's an ugly equation. If you ended up with 92,000 plus, you probably put it in right. Now here, we did 150 times 12 months, so that's again 1,800 times 20 years. We have invested at this point $36,000, but we're getting almost $93,000 in our retirement. Okay, so we have almost tripled our money, again, by not really doing anything, just letting someone else use it. All right, now most people don't retire in 20 years either. Most people work for 40 years. So how much would we have in our retirement in 40 years? All right, so go ahead and write the equation, put it in your calculator, see if you can do the whole thing. Remember, the only thing that changes in the equation is the time, so everything else remains the same. Your rate's going to remain the same. The number of times compounded remains the same. You're just changing the 40 in the time. And then see if you can type it in your calculator correctly. I think some of you will be a little surprised by how much you might have. Once you're ready, hit pause and then come back. You'll find out that you had over $500,000, $588,000, and all you invested was $72,000. Okay, you put $72,000 in of your own money, and it's now worth $588,000. Heck of a deal. I would recommend to all of you, as soon as you have a job, to start putting money away for retirement. All right, let's take a look at one other. Kind of working backwards here. Let's say we want to be millionaires when we retire. Okay? That wouldn't be half bad. So we want to invest in a Roth IRA, expected to grow at a rate of 8.6 over time. We start putting it in at 23. We want to retire at 65. How much do we need to put in? Okay, we need to figure out how much we need to put in each month if we want to be a millionaire when we retire. All right, so we need our million to be our end goal here. What we don't know is what we're going to put in each month. So we don't know our P value. But we do know our rate, 0.086. We know we're going to be putting money in every month. And we know that we're going to work for, if we're starting at 23 and retiring at 65, we're going to be working for 42 years. All right, so again, in our denominator, we have the rate divided by the number of times compounded. So we can find the value for all of this in here. You have to be really careful in your calculator. Add this first, take it to this exponent, then subtract 1, hit enter before you divide by this denominator, and put this denominator in parentheses when you divide it. So we're going to get that number. It'll be a decimal, and use your store feature. So you're going to have 4,962.7 if you did it correctly. And then we have to divide both sides by that. So you're going to take 1 million divided by that number. And you're going to find out that what you have to put away each month isn't that much. All you have to save each month is $201.50, which might sound like a lot to you, but once you get a job and a paycheck, if you can budget things well and put just $200 into a retirement account, then you would be a millionaire when you retire. Now, what if you wanted to make $2 million when you retire? Well, double that. Okay, put a little bit more in there. You can be all sorts of rich. Good luck.